Good evening, students. Myself Toshi Gupta, your physics teacher. We have discussed the Coulomb's law in the class already. So now we are discussing how to solve the numericals based on Coulomb's law. Some of the numericals we have already discussed. So we are discussing one or two questions more. So the question is saying if we have 2 point charges capital Q, each of magnitude plus 2 under root 2 microcoulomb are placed at the diagonally opposite corners of a square ABCD. On the remaining two corners, we have the charge small q, and we have to calculate the magnitude of small q so that the net force on capital Q is 0. Now we know force is a vector quantity, so we have to take care of the directions. For that, we are as basic direction is by Coulomb's law we say force acts along the line joining the two charges, and then we have to see whether charges are like or unlike. Like charges repel each other and unlike charges attract each other. So here for the time being, we are assuming small q is also positive. If it will be negative, we will get that value in the answer itself. So now if you see the direction of FB will be, force will be along the line joining B to A. Similarly for FD will be from D to A, and FC will be along C to A. Now net force on the charge at point A is 0. It means overall x component and y component should be 0. Now in square, the diagonal is at an angle of 45 degree. So we get for overall x component, value will be FB plus FC cos 45 plus FD cos 90, and overall value should be 0. If you want, you can take the vertical component means Fy as sine component also. The answer will remain the same. Now if we substitute the values by Coulomb's law, then we get 1 upon 4 pi epsilon naught small q into capital Q upon A square plus 1 upon 4 pi epsilon naught q square upon A root 2 का whole square into 1 by root 2 plus 0 is equals to 0 because cos 45 is 1 upon root 2 and cos 90 is 0. Now take the terms common. So we get this term 1 upon 4 pi epsilon naught q upon A square common. Within bracket we get small q plus q upon 2 root 2. Now since this term can't be 0, it means the term inside the bracket has to be 0. So we get small q is minus q upon 2 root 2 or q is minus half microcoulomb. Now second method can be, because since the force at point A is 0, so capital Q and capital Q, if we take the force Fc, that is in the fixed direction from C to A. But FB and FD will be different because their direction will depend upon the type of charge Q. Now if you see, if we take Q positive, then all the three forces are coming in the similar directions because FD and FB, their resultant will be along the diagonal also, and FC is also in the same direction. So we conclude if this force has to be 0, then the FC should be equal and opposite to the resultant of FB and FD. So result FB and FD are equal in magnitude. So we get F net will be FB into root 2. Then we calculate the value of FC. That has to be the magnitude wise FB into root 2. Substitute the values and we get again the same answer. Similarly, if we have to calculate only the magnitude, then we can, and only two forces are given, then we can calculate by the basic formula of parallelogram law of vectors. The resultant is under root A square plus B square plus 2AB cos theta. But this method of component is better because we can apply it in any situations, not only in this topic but in electric field also and questions of magnetic field also. Similarly, now take one more example where we are having a triangle ABC. Two charges plus 100 microcoulomb and minus 100 are placed at the point B and C of the triangle. Length of side is 10 meter. At the midpoint of BC, a charge of plus 75 microcoulomb is placed, and say we have to calculate the force on the charge of 1 microcoulomb placed at point A. Now again the same thing, we will see how many forces are acting at point A. Now this is positive charge, so it will repel. So FB will be away from the point B and along the line BA. Similarly, if C is negative, so now it will attract, so direction will be towards C along the line AC. M is negative, positive, so it will again repel, the direction is M to A and away from M. Now in equilateral triangle, every angle is of 60 degree. So if we take the components, the FB cos 60 and FC cos 60 will be along this direction. FB sin 60 will be upward and FC sin 60 is downward. Now again, we calculate the value. Now in this triangle, the value of AM is not known. So for that, we are having two options. You can apply the Pythagoras theorem. Secondly, we know by sine 60 degree. That is, the value will be a perpendicular upon hypotenuse is sine 60. So value of perpendicular will be 5 root 3 meter. Now we apply the values here. FB and FC are magnitude wise equal. So now in this case we are having three forces. So we have to take the components, overall X component and overall Y component. The X component will be FB cos 60 plus FC cos 60 plus FM cos 90. The overall value we calculate. We have to convert the value from microcoulomb to coulomb. Similarly, the distances, if they are in centimeter, then from centimeter to meter. But in this case, the distance is given in meter only. So we get the value of overall X component 9 into 10 power minus 3 Newton. Similarly, when we calculate Fy, then FB sin 60 and FC sin 60 are equal and opposite. So we get Fy is value wise Fm, and the value is again 9 into 10 power minus 3 Newton. So now the magnitude of resultant force will be again by the parallelogram law of vectors under root Fx square plus Fy square. So magnitude wise 9 root 2 into 10 power minus 3 Newton. For directions we have tan theta Fy upon Fx, that is 1. So theta is 45 degree. So when we have to specify the direction, we have to give the proper statement. The direction is at an angle of 45 degree along a line parallel to BC. Now similarly you can try other questions based on Coulomb's law, and we will discuss the remaining concepts of electric field tomorrow. Good day and take care.